Can you see that okay, or is it too bright in here?
Can you not turn only that light off?
No, it's stupid. All three are on the same switch. I know, I'd love to just turn this one off. Badly designed. Is it clear enough, or do I need the light off? It feels too dark with the light off.
It's okay.
It's okay. Well, we'll see. If it's
We open the curtains on.
Yeah, actually, that's a good idea. Much better. That is a good balance between the two. Okay. Right, what's the first question here? Do you have the questions in front of you?
Yep.
Yeah, okay. Okay, give me the information in the first one, so.
An apple with 100 grams. Yes.
Falls on a sleeping physicist, is that it?
Yep.
Yes.
With an acceleration of 10 meters per second approximately.
F equals ma. What's the m?
0.
The m is 100 grams, so that's 0.1. And the a is about 10. So the answer is 1. And the unit is? 1 Newton. Get my joke?
Yeah.
It can hold your laughter back. 1 Newton is the answer. Yeah. All right. Number 2.
So 2.5 kg ball is dropped from 49 meters.
Okay. 2.5 kg
Yeah.
from 49 meters.
Yeah.
Okay.
How much force is being applied to the ball as it falls, and what do you think is applying this force?
Right. So there's a force here, and the force is equal to ma, and the m is 2.5, and the a is 9.81. .5 newtons is the force. And what do you think is applying this force? Yeah, we haven't talked about it yet, but it's a force called gravity, yeah. Okay, what's number 3?
The car is being tested for safety.
Yes.
2000 kg is driven into a wall. The car hits the wall at 20 meters per second. The front of the car, which is 1.1 meter long, begins to crumble, and then finally the car is brought to rest. How much force is the wall applying to the car while it is decelerating?
So what is happening here is the car is traveling at 20. Then the car hits the wall, and the front of the car crumples. You've seen car crashes before, so the front of the car crumples in. And what's happening is, as the car is crumpling, now I'm sorry if you don't know this verb, do we know that some people may not? Do we know any other verbs for crumpling? Crashing, yeah. Yeah. Shrinking, compressing. Squishing, squashing, reducing, all these verbs. So, as the car comes along, the front of it crumples into the wall. And during this crumpling, it's slowing down. So it's decelerating. And remember I said, if there's an acceleration, then there's a force. So as the car slows down, the wall is providing a force to slow it down. So we know that the car starts off at 20, but finishes at 0. The A we don't know, the T we don't, but the S we do know. The front of the car is 1.1 meters long. So V squared equals U squared plus 2AS. That's 0 equals 400 plus 2.2a. So I get A is minus 181.8 meters per second squared, which is fine because that's what I need to get the F. F is MA. So if I multiply this by 2000, I get a very big number, 363636 newtons, or what's that now? That's kilo, that's mega, I'll go with kilo, 364 kilo newtons is my answer then.
Could we write
0.6 times, yeah. I like the prefixes though, but that's fine. Okay, so that's number 3 there. If you didn't get it, you'll need to write it down. 1 and 2 you should get. 3 maybe was a little hard. How many questions are there now? 5? Yeah.
So we round this up.
Yeah, because it's 3636.
So do we have to round this up, or could we just write?
You have to round it.
Like I got 3.63600.
You got what? 3 point.
63600.
Yeah, that's fine too. Okay. All right. What's happening in 4?
80 kilograms space probe is traveling at 20 kilometers per second. It then engages its proportional system and accelerates for 3 seconds.
So it's 2 kilometers per second.
2 kilometers per second,
Yeah.
and it activates its rockets for 3 seconds.
Yeah.
And what happens now? It gets faster. It goes faster.
The system is capable of delivering 1 kilonewton of thrust.
Ah, I see.
How fast is the probe going after it accelerates?
Right. So you know the F is 1,000 newtons. MA is 1,000. So then A is 100 over 8, which is 12.5, isn't it? Yeah. So the acceleration is 12.5 meters per second squared. The U is 2,000. The V is what we want, is it?
Yeah.
Yeah. The A we know. The T we know is 3. All right. So V equals U plus AT, is it?
Yeah.
V equals U plus A T. That's not too much faster.
37.1
2037. So 2038 meters per second, if you want to round it. Steady. Okay. Was that the only thing in 4? Just the.
Yeah.
How many were there? 5, 6, 5. Okay, one more. Oh. Okay, 5 now.
75 kilogram man jumps from a height of 2 meters.
This one. Okay, so this one is a bit hard. I know this one. So he's at a height of 2 meters. Okay.
He's 75.
And he's 75 kg. Okay.
The man bends his knees when he lands and therefore decelerates over a distance of 20 centimeters.
Okay, so let me just try and visualize, or help you visualize what's happening. So when he lands, as you know, your legs bend, and the reason for this is to help you slow down. Your legs don't stay straight, and basically what happens is it's like with the car. He decelerates over a distance of 20 centimeters. He doesn't instantly stop. You know, it's not like you hit the ground and instantly stop. You actually slow down on impact. And he slows down over a distance of 20 centimetres, and the 20 centimetres is because that's how much he can bend his legs when he lands. Alright, so what do we ask for first?
The man bends his knees when he lands, therefore decelerates over a distance of 20 centimeters. How much force in total does his body feel when he is decelerating? Okay,
so when he's landing on the ground, he's decelerating, so there's a force. So F is equal to ma. So you think, oh, okay, so I know the m. But the a is not 9.81. Only when he was falling was it 9.81 down. But now when he lands, there'll be an upward acceleration. So, what I'm going to do first is work out how fast he's going here before he hits the ground. So, v squared equals u squared plus 2as. V squared equals 0 plus 2 times 9.81 times 2. So V will equal square root 2 times 9.81. So he is going at 6.26 meters per second when he lands on the ground. And then here he bends his legs, and this will cause him to slow down and come to rest. So now we have u equals 6.26, v equals 0, a is what we want, t we don't know, and s is 0.2. So now we can work out this a for this bending part. V squared, no, s equals is better?
Or you can use v.
I think v squared might be best here. We can say v squared equals u squared plus 2as. So 0.4s.
How did you find out that u was 6.26?
Because the u for this part is the v for the previous part. So like what's happening is we worked out the v for when he gets to the ground, and then that's the start of the part where his legs bend. So that becomes the u, and then the v for this part is 0. The s, oh, what am I doing? I meant to write a here, because we know the s, that's an a, sorry. So the a is much bigger. It's not 9.8, it's like 10 times bigger. It's 98.1 meters per second squared. So the a is so much bigger because he has to slow down quickly when he lands on the ground. So now we can work out the f. We multiply this by 75, and we get the force he experiences is 7,358 newtons, or in other words, 7.4 kilonewtons, whatever. Well, 7.36 I should say. Okay, so that's the force, which is a lot. What's the b part?
If he only bends his knees by 10 centimeters, then how much force is he experiencing?
So in the second half we just do it again, but the only difference is, but instead of 0.2 here, it's 0.1. So I won't rewrite everything, I'll just recalculate it here. So now the v will be square root, well, the v is still the same, 6.26, it only changes for this part. Yeah, it should actually be twice as big, I think. Yeah, okay, and then times 75. Yeah, it is twice as big. So you get 14.8 kilonewtons. So half in the distance for bending the legs doubles the force that he feels. which kind of makes sense because he has a shorter distance to decelerate, but he still needs to decelerate from 6 to 0 meters per second. So shortening the distance means he requires more deceleration, and so he needs more force. Okay, so what's the last part, C?
Assuming that the human leg can withstand 9 kilonewtons of force from a fall before it breaks, and assuming he bends his knees as much as possible, 50 centimeters, what is the maximum height he could jump from?
So, the maximum force before your bones start to break is 10 kilonewtons. 9 kilonewtons. 9,000. That means 75A is 9,000, which means the maximum acceleration is 9,000 over 75. So it's 120 meters per second squared. And was I asking for the greatest height, was it?
Yep.
Yeah. Now, if we look at the UVATS, so what I'm doing is I'm going backwards. We still know the V should be 0, but the U will not be 6.26 because we don't know the U, because we don't know the height that he jumped from. But we know the V should be 0, we know the A should be 120, or really I suppose if we're slowing him down it should be minus 120. T we don't know, but the S we do know is
50.
0.5, yeah, 50 centimeters. Yeah. So let's calculate the U to see how fast he can go when he hits the ground, the maximum speed. What formula would be best? V squared again? V squared equals U squared plus 2A S. So the fastest he can go when he hits the ground is 240 times 0.5 square root. So he can go as fast as 10.95 meters per second. So now we know that he hits the ground at 10.95, but we know he starts at rest, and this time we'd like to work out the height, and we also know the acceleration is 9.81. So again, U is 0, V is 10.95, A is 9.81. Now I'm being a bit careless with my signs. I should be using minus, but it doesn't matter. I know it'll work out. UVA, T we don't know, S we don't know. What formula can give us the S easily? Is it again V squared equals U squared plus 2AS? V squared equals U squared plus 2AS. Okay, this is probably unrealistic. 6.11 meters.
No, it is very realistic.
Yeah, it might be okay with 6.11 meters. Tall, but yeah, okay. Just about realistic.
We're very fragile.
We are fragile, yeah. Although, yeah, you know, he bent his legs 50 centimeters. He started from rest. 6 meters would be about the top floor, the second level of a building.
It's longer than a bus.
No,
It's a bus. The bus is 4,362 millimeters.
the length or the width?
The length of the bus, so it's longer than a bus. So if you stand the bus and a half, and then he jumps from it, that would be around 6.7.
A bus and a half in height.
Yeah. No, not high. Then you stand them upright.
Yeah. No, I don't think a bus is 4 meters long, because that seems too short. You probably mean 4 meters high.
No, the bus is 4 meters.
No, because...
That's what it's written.
No, that must be a different dimension. That must be the height or the
When you
width.
go back home today, check it.
I will check it.
Because I look at it every day and I think about it. This was not... The bus is longer than 4 meters. But that's what it's written.
Okay, I'll look when I get on the bus going home and see. 4 meters would only be from like here to the door. Maybe not even that. No, but about that, yeah. Okay, is that the last one then for that? If anyone wants to test if their legs break, I think we're about 6 meters high. Be my guest. Okay, let's go on to the next topic. So,